All right, we better start. When Bilal comes, then we'll give him a chance. Bilal, when you come, if you're here, just unmute yourself. Okay, guys, anybody who's not talking, just mute yourself for now. Okay, just mute yourself for now, and then we'll start. Okay, let's go to the beginning. This is quite a long presentation. Can you all hear me?
Yeah.
And can you see my presentation?
Yeah.
Okay, so we're gonna start. Guys, so whoever is not talking, just unmute yourself, please. Oh, there's some noise in the background. Let me just look at the Zoom thing and admit all. Alper, could you do me a favor and keep an eye on the waiting room and admit everybody?
Yes, I will.
Okay, please. Thank you. Thank you. That's very kind of you. And there is somebody who needs to mute themselves. Yeah, that's fine. Well done. Okay, so now let's start with the Mentimeter. Wait. What's happened here? Why is it not working? 1 second. We need to go to the first slide. Let me try and go back because this is a 40 slides. So we need to go back to the beginning. Actually, we might have. Here. Yeah, create this one. Okay, fine. Oh no. Go back to the presentation. Oh, Alpa, if you could just let in the people in the waiting room as well. Okay, now you guys can obviously see my presentation. Let's start from the beginning. Okay, now for those not familiar with this, please go into Mentimeter and put in the login, menti.com, and use the code 72571075. Now, we'll go over this in a few minutes again. You can also use this QR code. Bismillah ar-Rahman ar-Rahim. This is a verse from the Quran. Guide us to the right path. And as scientists and researchers, up to you to exercise your minds and talent to seek out the ways and methods to accomplish great feats of learning. You stay in contact with one another, and particularly with those who are working in similar areas of research and learn from each other. This is a quote from Mirza Masroor Ahmad. Okay, if you could master any skill, what would you choose, guys? Any skill. Guys, any skill. Can you use the code and type it in? Also, all of you who have phones and have a Microsoft 365 account, can you please download Minecraft Education on your phone? Alper, just let everybody else in. Let me see. Admit all. Yeah, so what would you guys choose? Oh, fishing, painting, research, use of language. Very good, very good. Brilliant. Some good answers there. Sign language. Oh, yeah, that's interesting. Coding. Okay, fine. Fishing. Okay, time to tell. Okay, fine. So time to tell some stories about research. At UCL, a group of researchers was conducting a study on the effects of new dietary plans on blood sugar levels. They had collected vast amounts of data and now it was time to analyze it. The team was divided between using two methods, which were standardized mean deviation and mean deviation. Yeah. So try and remember that mean deviation is a scale, let's say height, Yeah. And what you do is you see if the difference between me and the other person, let's say 2 inches. Standardized mean deviation means we take the square root of it. Now, this is interesting enough, has a lot of ramifications. What it does is it makes the differences larger. Yeah. Obviously, if you square, if you sorry, not square root, if you square something, obviously it'll be much larger. So that's why standard mean deviation is a bit larger. It is very, very useful if things are measured on different scales, because we'll standardize the scales. So standardized mean deviation measures how much each value in the dataset varies from the mean. It captures both small and large variations and is useful in detecting even minor changes and providing a detailed understanding of the data. But however sensitive to extreme values, this is exactly what I was talking about a minute ago, is because of the way it is mathematically, which can distort results. So if you have a very, very big result, the number will become much bigger. Yeah. So if somebody, let's say in your population, is 9 foot tall, his height would be doubled. He'll have an even bigger effect on the data. The team was torn. Some believed that sticking with standard mean deviation was the right path, often used with detailed analysis and depth are needed. Others felt mean deviation would provide a clearer and more accurate picture when outliers were present. Shall they use SMD or MD? So your answers are SMD, MD, neither, I believe I can fly. Which one is it? I believe I can fly is very popular. Can anybody sing I believe I can fly? This is a very important point about I believe I can fly, which is the guy who sang I believe I can fly can't fly because he's in prison. Yeah, he's in prison for a long time. So he absolutely cannot fly. I don't know if he's in the same prison as Puff Daddy. Yeah. Okay, so SMD. Okay, good choice. Oh, wait. No, went forward a bit, too many slides. I think you guys do this. So then the team continued with standardized mean deviation. Initially, it seemed like the best choice. It offered precise insights, capturing small variations and trends clearly. The SMD is best used when detailed analysis is required, the data has minimal outliers, so outliers are an unimportant part of the analysis. You want to understand the exact spread of the data in relation to mean. So basically, it gives you a little bit more detail, but outliers are present, that's pretty bad, okay? When should you use mean deviation? Yeah? When should you use mean deviation? What do you guys think? When should you use it? Obviously, when more outliers are present. Another way of thinking of this is that what you're doing is with standardized mean deviation, you're modifying the data. Yeah. But with mean deviation, you're not. And it is exactly as it is. But standardized mean deviation can look at the differences much, much more accurately. Because by squaring up the differences, you actually get a better, a more, it looks at the differences more clearly. Okay. Very good. What does SMD stand for, guys? Bosses, what do you think? What does it stand for? Standard mean deviation. Standard mean deviation. Standard mean, yay! Lots of people got that correct. Now, imagine the Rosetta Stone. So the standard mean deviation is like Egyptian hieroglyphics. Hieroglyphs. It is complex, intricate, filled with detail. Hieroglyphs, when properly understood, reveal a deep and rich meaning, but they also capture every single more detail. So hieroglyphs were these Egyptian picture writing, which were really detailed. It's like the old Chinese writings like that as well. So everything had a picture, even a book. They had a word, a picture. You had to learn thousands of pictures to be able to write. So SMD measures how much each individual data point deviates from the mean and considers the squares of these differences. In contrast, the mean deviation just calculates the average of the absolute difference between each data point and the mean. It's a simpler measure, less influenced by outliers, and is suitable when you want a general sense of the data dispersion without the influence of extreme values. So the Rosetta Stone contains, anybody know what the Rosetta Stone is? Guys, unmute yourself if you know what the Rosetta Stone is. No? Yes? Has anybody said anything in the chat? No? Okay, fine. Everybody's absolutely quiet. Okay, so the Rosetta Stone contains the same text in 3 different scripts: Greek, Demotic, and Egyptian hieroglyphics. Hieroglyphs. By comparing these scripts, scholars were able to decode the hieroglyphs. This was actually a message sent by one king to another, so you wrote it in 3 languages. And because they knew the Greek, they were able to work out, especially the Egyptian language. So the SMD and MD are like different scripts that researchers use to decipher the language of data, providing a unique lens. What is the Rosetta Stone? Is Boris Johnson's old house, a form of jewelry, a level in Minecraft? It's 3 different scripts. Absolutely. It does. Brilliant, guys. So the standard mean deviation measures the spread of data around the mean by calculating the square of differences from the mean and then taking the square root of that average. Yeah. So the spread by calculating the square of the differences from the mean and then taking the square root of that average. It captures both small and large variations, making it useful for detecting even minor deviations in the data set. Yeah. So you process it twice. So you square it and then you take the square root. Okay. For example, if they had blood sugar readings of 100, 102, 98, 105, and outlier 150, the SMD would reflect the larger spread caused by the 150 value. But the problem is, it gives that 150 a lot of importance. Contrast mean deviation calculates the average, known as absolute deviation, average absolute deviation, calculates the average of the absolute difference between each data point and the mean. This approach is very simple and less sensitive to extreme values. You have to remember that if you have multiple scales, let's say, things are measured on different like quality scales, then you have to use SMD, because SMD is actually will equalize all the scales. Yeah, will equalize. SMD has to be used if you're on different let's say different scales are used to measure the same thing. But then you have to think of it like the Rosetta Stone, because it uses the range of it to basically equalize them. So I mean, this is not something you want to get into too much, but in essence, if you have different scales, you can use SMD. SMD will standardize it. But normally, if there's not too many, if there are too many outliers, then MD is the better approach. Yeah? So in that case, in the same blood sugar patient, the MD would average the absolute difference from the mean, giving a stable measurement, even extreme values like 150 at present. So SMD provides in-depth understanding of the data, including smallest fluctuations. It's good if you want a comprehensive and precise meta-analysis. However, as hieroglyphics can be confusing if you focus too much on the individual symbols, while understanding larger picture can be distorted by outliers or extreme values, making interpretation difficult if the values are not properly managed. Oops, sorry. Let's go back there. So when should you use each? SMD, detailed analysis, when you need to uncover deeper patterns in your data, much like deciphering the hieroglyphs when you need a precise and full understanding ancient message. And 2 is when there are minimal outliers, as these outliers can skew the data and obscure the character story your data tells. If you have outliers, which one should you use? Oh, wait, he's in the waiting room. Bilal, I think he's come. Let me admit him. Admit. Okay. Should you use SMD? No. Great. Brilliant. You guys have solved it. Happy with that. Mean deviation. So demotic script, like, the Rosetta Stone, the demotic script is more like demotic script. Simpler, streamlined version, the same language. And it was for everyday communication. The hieroglyphs are more complex. So the MD is just the average absolute deviation of each data point. It doesn't square the differences. So it's less influenced by extreme values. However, it doesn't account for outliers or minor different variations, same as SMD. Now, if you have lots of outliers, better to use this one because it's simpler. So is a quick and effective use. You understand the general trend, like the demotic script offered a straightforward interpretation, same message without too much detail. If there are outliers, should I use MD? Yes, no, I don't care. I want to go to sleep. Which one, guys? And in a minute or two, we'll get, after we finish the story, we'll get Bilal to talk before the next story. Yes, we should. Nobody's chosen. I want to go to sleep, actually. No. Fine, next one. General overview. Use MD when you want a clear, uncomplicated view of your data, free from the influence of outliers, like reading the demotic script for quicker understanding of the ancient text. Outliers, if you have lots of outliers, then MD is effective. MD is very effective. Now, as continuing with the story, they dwell deeper. They notice extreme values like few unusually high blood sugar levels skewed the result, making the overall trends more extreme they were for most patients. Their confidence faded as discrepancy emerged. The group discussion turned into arguments. They were fighting. They need over MD and SMD. They needed a new strategy. Actually, nobody got murdered, but some people might have got injured actually over this complex, statistical problem. Should they switch to a simpler approach? Should they push forward? Which one? SMD, MD, neither. The Kardashians. We should ask the Kardashians. Which one is? To MD, yeah, because they've got lots of outliers, isn't it? Ooh, 2 is winning. 2 is winning. Nobody's voted for the Kardashians, yeah. Oh, Kardashians are winning now. The Kardashians are in now. The Kardashians are nearly there. Nearly there. Neither. Kardashians are still doing well. Still doing well, the Kardashians. Still doing well. Okay, very good. Realizing the limitation of standard mean deviation, the team switched to mean deviation. This method was less sensitive to outliers and offered a clearer, more stable picture of the data. And then mean deviation works best when the data has significant outliers. So you have a simplified, you want a simplified general sense how far the data points up to the mean, and then you want the central tendency rather than the fluctuation. So as we said, it's a simpler language. SMD is a more detailed language, but very sensitive to outliers. Okay, they calculate MD and minimize the impact of extreme blood sugar levels in an accurate way. The project was not yet. However, the team soon noticed that MD didn't capture finer variations, smooth out the differences, but hid small but important patterns. To unsure they made the right choice, should they return to the original method or stick with a simpler approach? They tried to adjust SMD, hoping to minimize the outliers. It was time-consuming, led to exhaustion. The SMD was careful consideration faced with extreme values, as it could distort the data. They needed something different. What should they do? Should they switch to MD? Should they go to SMD? Should they do both? What should they do now? Should they fire their team? Should they travel back in time? Use both. Do both? Oh. Well, the answer is that your meta-analysis would look really weird if you did both. What you should do is, in this case, probably we would do MD because the data is quite variable. You could do, actually, interesting enough, you could do maybe a sensitivity analysis in this case. Sensitivity analysis. Oh yeah, sorry. Somebody else is coming in. 1 second. A sensitivity analysis, that would be possible. But I think MD overall. You have a mean statistical method, yeah? Okay, now you have to imagine this guy is deciding between MD and SMD. Can you put a pin on his mouth? Put a pin on his mouth. Let's see if you guys can do it. His mouth is moving, but put a pin on it. Is it working? Oh my God. Getting close. Closer. Close. Yes. Yes, somebody's, well, oh, okay, fine. You complete me. I love you. It's terrible. Terrible. Okay, so that story is, so sticking with mean deviation, the team feels relieved fewer distortions of outliers, they soon realized mean deviation missed subtle variation, making it less effective, called detailed trends for their study. Was there a way to balance this? Which one? NSYNC, Boyzone, SMD, MD? Are you going to stick to your guns, guys? Are you going to go with MD or are you going with SMD? I think Boyzone was better than NSYNC. I think. And those who don't know the 90s boy bands won't know the difference, to be honest. No. You know, Justin Timberlake come from NSYNC. You guys don't. Very sad. Nobody even knows that. I don't think even any of you know who Justin Timberlake was. Okay, fine. 2. My God, MD is in the lead. Very good, correct? To be honest, here. Now, we have to guess. I think we'll leave this one. This is guess a number between 1 and 7. SMD use less detailed analysis required, minimal outliers, or outliers an unimportant part of the analysis. You want the exact spread of the data in relation to the mean. Unimportant part of the analysis. Mean deviation, a lot of outliers, simplified general sense, and you want to understand the central tendencies. So I thought I'd go through this again. Do you guys have any questions about this before we bring on Bilal? Any questions? Bosses? Everything clear? You guys have learned all of meta-analysis in 5 minutes? Hopefully. No, thank you. All right. Now, before we go on to the next story, what I'll do is I will let Bilal, if you can unmute yourself. And what I'll do is I will stop sharing. Cancel. How can I stop sharing? Okay, I think Bilal, if you have something to share, you can share it. But otherwise, just tell us about the meta-analysis you did.
Yeah, so I'm actually not on my computer, so otherwise
you can just talk through it.
Yeah, sorry. So essentially, I think I started around February time when Dr. Ahmed, you gave me the suggestion for a title on a VA ECMO.
Yeah.
So essentially, what I did was I kind of got a team around me of some other students that I know. So firstly, I'm a fourth year student at King's College London. I'm currently on placement at Psych. But essentially, in February, Dr. Ahmed gave me the kind of title. So then after that, I got a team of other students around me who also wanted to take part in meta-analysis. And I knew them from before. So I knew that they were kind of interested in this stuff and that they were, willing to work hard. Normally, sometimes some students find it difficult around exams times and stuff. So it's good to try and start, like, for example, now, I don't have many exams coming up. So it's it was an okay time for me to start. So then we started, we did some kind of initial searches to see if there were any papers out there at all, which we could use, just like a quick PubMed search. We found a couple of papers, so we thought it'd be worth, taking the risk of doing the whole full what's it called, real search on PubMed, Medline. We got the search strategy together, based it off the other papers. Also, ChatGPT is great help for this, because you input the search terms from other papers, and then tell it to kind of combine it all into one search, and it gives you the search terms really nicely, and it covers pretty much everything. So that's one good thing you can use ChatGPT for, one of many. Then from the searches, we basically imported it into Ryan. Then from Ryan, we did the screening. It was me and another student that did the screening. At the same time, we had some other students getting along with the kind of introduction, doing other stuff in the meantime, so that we can kind of get this project going fast, and that doesn't take too long. Prospero registration, stuff like that, you can do at the same time. Once screening is done, you can start doing risk of bias. So once you have the papers, essentially, you can start doing risk of bias. One person could do, and another person can start doing the actual meta-analysis. And then once that's done, it's basically just results and discussion, to be honest. And so all in all, this kind of whole process, including the reviews and going back and doing more analysis. It's taken me up until maybe last month I submitted it. So I guess that's around 6-7 months, which alongside university and stuff, I'd say is it's not too bad. And I think just putting the effort in and then kind of seeing the end product is really nice.
Okay, Bilal Sahab, I'm just showing your paper.
Yeah.
Let's see. That's fine. Do you want to talk about any part of it?
Yeah. So is this like the most up to date one?
I think this is the last one you sent. Oh, this is the central illustration. Oh.
Yes. So this central illustration actually one of the students made on Canva.
Nice.
So it was really good. Canva was really good for this. I'd really recommend people to use Canva. They have the templates already, really quick and simple, and it looks nice as well, which is a
you did.
big
So there's
positive.
key points. So I just wanted to show them all the bits. So
yeah. So essentially, once you, I think Dr. Ahmed, one important point to mention is that once the paper is actually complete from our side, or essentially once it's like kind of all written up, one of the next things that takes quite a bit of time is actually formatting it in the right way for the specific journal that you're submitting it to, especially the abstract. So like there's different journals require different abstract formats. Some will have certain like subheadings, some will have no subheadings, some require only a certain word count and all of this. So basically after you finish writing the paper, you have to allow for about a couple of weeks just that you can format it in the right way and kind of tick all the boxes for the journal. I think that's quite an important point.
Very good. I think one thing I would say is that this is, in a sense, a paper is a documentation of all the stuff you did. So even though this looks like a lot of dense text, when in reality this is documentation of all the work that you did. As you can see, it's been heavily edited. God, every line of this has been edited so much.
Yeah. Yeah, exactly.
Yeah, but this is what gets it over the line, isn't it? Is that polish? Otherwise, the problem is that meta-analysis is very easy, I'd say, to get a what's it called, a conference abstract, but to get a paper it requires a tiny bit more effort. Okay.
Yeah.
This is very nice, actually. In the end, it was very, very nice, and I'm just going to bring it down the forest plots. Where were they?
Yeah. I think the forest plots were in a separate document, were they, or were they at the end of this one?
I'm forgetting now. This is 54. This is all the references. Nothing is here. So this was the Prisma. Now there's one important thing in the Prisma, which Bilal Sahab has done very nicely, is he's put why he excluded each paper. Yeah, and this is the screening, reports, and full text. Full text you need to put in why he excluded them, because people question this. The first thing they look at in the paper is this. This is risk of bias. This is the funnel plot, which we'll talk about a bit today. It looks very, very nice. I know that this is one important thing to understand is this is a very much a team effort, and it doesn't take as long to generate as you would think. Actually, my boss used to do one-man meta-analysis at one time. Anyway, yeah. Sorry, Bilal, you were saying?
Yeah, no, exactly. So like having a good team around you is really important, but also knowing how to manage the team, like making sure students are doing stuff at the same time. So you don't have to. It shouldn't be like we're waiting for one person to do this, then another person can start doing this, then another. Otherwise, it would take like over a year. Lots of stuff needs to be happening kind of simultaneously. For example, the introduction can be written at pretty much any point. Like you don't have to wait for the introduction. Also, methods is going to be similar to previous meta-analyses, and just there's general methods for meta-analysis. The finer details can be ironed out later, but that shouldn't be a reason why someone can't write it straight after writing the introduction whilst you're still doing the analysis, for example. This can all be, and then the finer details can just be ironed out or inputted later. So I think kind of making it as time efficient as possible is really key, because the later it drags on, then people start to lose motivation, and then other things come up, and it's just really drastically decreases the likelihood that you're going to end up with a paper that is, that you're able to publish. So it would just be like lots of effort, and it goes to waste essentially.
Bilal Sab, if you were to offer these people a word of advice, what would you say?
I think just try and like so basically try and make it as efficient as possible and put in as maximum amount of effort at the start as you can, because once it kind of tails off, once the effort from you, especially because obviously it's going to be your meta-analysis, you're going to be the one that's the most motivated to do this. So once you drop on the kind of motivation and on the effort side, everyone else will just follow you. So really try and do this, especially at the start. Try and get it done, in one block. Have something always going on. Don't let other stuff get in the way. And yeah, honestly, if like I found through this paper that if I was able to just work hard, then it came together in the end.
Yeah. Bilal, by the way, you were quite quick actually. I know you're saying it's in February, but in reality, you did the first. But there was a bit of a false start. But after that, we zoned down on the topic, you actually finished the main paper. I think it was in 2 months, 2 to 3 months.
Yeah, and then also like another thing with research that obviously everyone knows, but it's worth mentioning, is that sorry, I just got to call. So one thing that everyone knows, but it's worth mentioning, is that you're racing against other people here, and it's a race against time. So even if it's not just motivation, imagine if you put in all the effort and then someone else kind of publishes before you. So you can do Prospero and you can register yourself in Prospero, but at the end of the day, it's first past the finish line. So really try and get that time efficiency like done well. And yeah.
Brilliant, Bilal Sab. That was very good. Now, the important thing is that Bilal Sab had actually very little help from me, which is quite unusual because most of my past projects I've managed very, very heavily down to what each person was doing and etc. When Bilal Sab's project was very unusual, he actually did the whole thing himself. Which is, well, in the past has not ended well because a lot of times so this is why we're probably going to provide a bit more supervision, because in the past people have done projects which have had some difficulty. In the end, we sorted them out, but we've had some. But Bilasa was able to somehow do all of this with minimal supervision, so which I still haven't worked out how.
Do you know what? I think that's actually another good point. That like, ChatGPT is very, very useful. Like if I didn't understand something before, I'd ask you, Dr. Saab, I would ask ChatGPT, and most of the time it gives me a good enough answer, and then I can go off and figure it out myself. So that's one of the ways that we can use kind of technology to speed up the process as well. Just to kind of get ChatGPT to explain it to you, or any AI to explain it to you, and normally, it has the right answers, even down to the fact of like, what does this graph mean? Should I use this graph or this graph? All of the different technical details. You can kind of get ChatGPT to do it.
Okay, guys, do you have any questions for Bilal? You have to remember, this guy is a bit of a celebrity in my mind because he's finished a first author meta-analysis as a 4th-year medical student, which is quite an achievement, So you guys can ask any questions if you want. Guys, the silence is deafening.
It's okay because they listen to the advice of asking ChatGPT everything. So now ChatGPT.
Yes and no, but ChatGPT is an intelligent parrot. It can't really think. But yeah, you're right. It can usually tell you what it does is it's in essence like a search engine where it takes all of the things different people have written and sort of brings them together. So you have to understand how it actually works. It can't learn, for example. You know that it's not intelligent. It can't learn. So there's various things about that, which basically means there will always be semi-automation. It has no real intelligence. It only has the intelligence of all the human stuff that's been fed into it. So it seems intelligent, but that's only because it's parroting all these humans who've said something about something. It doesn't know that the toilet doesn't go in next to the kitchen, for example. It'll give you a really good map, but it doesn't know. The human would know that because the human thinks. So ChatGPT lives off human thinking. It doesn't have its own thought process in reality. Yeah. Okay. Bilal Sahab, Jazakallah, thank you very much for that. I'm going to
No
get
problem.
on with the Mentimeter, the second story. Bilal, you can attend if you want. You can see how I teach. So there's some new techniques, obviously. Okay,
I did. I saw the first bit, but I'm just revising for something. I'm gonna have
that's
to head off.
no problem, no problem. Thank you.
Okay.
Okay. All right. So you are thank you very much. You are leading a team of researchers at a university. Now I'm going to talk about the situation Bilal described. At a university in London, your mission is to complete a meta-analysis that could change lives by identifying the most effective treatment of heart disease. Beginning, your team is united and hopeful. As weeks go by, challenges pile up. Your funding is running out. Progress is slow. Disagreements are escalating. Fear begins to grip the team. You must navigate these obstacles and make critical decisions to keep the project alive. Oh my God. It's like a Tom Cruise movie. The funding for your project is nearly exhausted. Team members are growing anxious. Even James Bond has left the team. And some are suggesting they split off to work independently as independent assassins or something. Others argue that continuing is a loss because the team morale is low. And fear of failure looms. That's very bad. What do? Gather the team and speak with clarity, offering a shared vision. 2, ask the team. 3, fire the non-funny members. I don't know. I think firing the non-funny members is a very good approach. There are lots of non-funny people out there, including myself. They're not funny at all, and I think they should be, fired. Or actually, it could be that the funny people were distracting the team. Okay, very good. That is probably actually gather the team and speak with clarity, shared vision. Why are we doing this for? Yes, if we're doing it to help humanity, we all need to work together, etc. Something like that. Yeah. So you need to offer like a rousing speech before the battle. You gather the team, remind them of the purpose behind the research. You emphasize the need for unity and clarity. You propose a structured plan. Now, this is important, obviously, that you need to have a clear plan, dividing tasks based on each. So, what is the strength of each person? What is the weakness of each person? And that's quite important. You have to work in unity. Give them a voice. This is very important. Never do anything without asking people. Keep in contact with them. If your team, the way to keep them motivated is text them every week or every second week, whatever. Ask them what do they think about the topic? What do they think about the way we're doing screening? Keep getting input of them. Sometimes you might think, somebody is quite junior, but to be honest, like a lot of this class comes from ideas from my 11-year-old daughter, because she says, oh, in school they teach us in this way and that way. So I took a lot from this. So structured plan. So they need to see if you've got a plan. Divide the task based on each member's strength. You said regular checkpoints. Okay, let's check what everybody's doing. You don't just let people drift. Okay, you're doing screening. Okay, fine. Like 3 months later, you check. Oh, did you do the screening? Well, I did it in the wrong system or whatever. Yeah. So you need to check what each person is doing, where the team can regroup and address challenges together. And that's very important. That sometimes when you divide up the tasks, each person thinks, oh, only my task is important. But whereas the team should feel we're all together, we all have input. Try and do polls. WhatsApp polls are quite useful, actually. And things like that. The team is reassured, agrees to move forward as one. There's a sense of renewed purpose. You feel hopeful. You can overcome the obstacles. You gather the team, reminded of purpose. You find a treatment to save lives. Even the path seems uncertain. You must shared goal. We are stronger together. And then what happens? Oh no, another setback. Key team members leave. They say go bye-bye to you, yeah? They don't like you. And they said you weren't funny enough, actually, which was quite hurtful. Exhausted by the relentless strain and lack of progress, and the fact that you could only tell them one joke in 6 months. The project is at risk of falling apart. Those who remain are filled with fear. If they continue, they may waste what little resource they have left. But giving up now means accepting total failure. The weight of I strongly believe in this, that if you fail, the penalty is very high because everybody's effort is wasted. And that's quite sad, isn't it? The weight of the decision feels as heavy as death itself. What do? Give up. Push the team to take immediate action despite the risks. Encourage the remaining team to pause, reflect, and find a middle ground that balances the risks. That's probably correct, actually. Nobody gave up. Nobody gave up. You're presented with a beautiful chocolate bar. You're trying to lose weight, but you give up and eat a chocolate bar. So that's a reasonable strategy, actually, in front of a chocolate bar. You remind the remaining team members of the need for patience and balance. You suggest they pause to review what has worked, what hasn't, ensuring they find the right way forward. Discussion and reflection. Yeah. So you need to ask but not get them to fight. You need to basically avoid arguments, but just say, what can we do? Yeah. But don't let people attack each other. This is very, very important, because if a person is attacking another person, that it can't be allowed. That absolutely cannot be allowed. Yeah, because we all work together. We have to try and celebrate people, say positive, you've done this well, thank you so much, I'm so grateful. Don't make people feel like they're servants. Everybody in the team should be equal. This makes everybody happy, because nobody's actually happy being special. Yeah, this might seem odd, but special people are not happy. By encouraging discussion and reflection, the team identifies a solution that blends caution with action. You pair team members to support each other. This is a great strategy. Pair two people together, and they can work together, and then they don't get bored, because research can be quite boring, like screening or data extraction. Say, why don't you two work together? This shared responsibility begins to restore strength and trust. With the fear of failure is still present, the team moves forward with renewed focus. The one other thing that does work is to get new people in, because if people have given up, maybe you should just get more people in, but give authorship to the previous people. Just always be generous. Financial strain remains. The shared effort allows them to research and stretch their resources further. The team has managed to make significant progress. They're near the end. One final test is exhausted. Financial pressure, fear. Some people feel ready to give up. Their efforts might end in failure. A moment of deep uncertainty. My God. What do you do? Remind the team of shared purpose, avoiding steady guidance and patience. 2, insist the team move forward without rest to reach the finish line. 3, laugh like the Joker and Batman. That's actually reasonable strategy, actually. Team forward, yeah. So don't push your team. It's voluntary, and they're going to leave if you do that. They're just going to leave. In all honesty, if you treat them badly, they're just going to leave. So this is why I don't like deadlines. I don't really give my team deadlines, because I don't think they work. What works is weekly contact and motivation. Yeah. You say, oh, well, you just this task needs completion. If that person is unable to do the task, don't judge them. Just give the task to somebody else. Yeah, without judgment. Yeah, because sometimes people have things going on in their life. Their mother might be ill. They might be being depressed or whatever. They could have various issues in their life. And sometimes these people who you think, oh, they didn't deliver in that last project, they end up being, really, really good later on. You should see the positive side of people always. Yeah. Okay. Any questions, bosses? Any questions? No? Okay. We're going to do some presentations, and then we'll do some blockade. Oh, wait. No questions. Why is this doing this? I think when it starts sharing, it becomes weird, the screen. And then we'll do some exercises together. Come on, computer, work. I think it's... Oh, yeah, sorry. I haven't shared the right screen. I just realized. I need to share entire screen. Okay. The topic of the day, publication bias. How to make this bigger? Publication bias. So more studies with significant results are always published. Those with negative results are underreported. Yeah, nobody wants to show that they failed. Journals do not publish negative results. It skews the overall results of meta-analysis when only the positive results are published, leading to overestimation of the effect size. It's quite sad music, actually. Okay, so that's interesting, isn't it? Any questions about that, guys? You can unmute yourself and ask. Guys, any questions about this? No? Okay. Now we're going to talk about this in a bit more detail again. So heterogeneity, oh, sorry, this was, this is about heterogeneity, but we'll do this as well. Heterogeneity. What is heterogeneity? Heterogeneity is the fact that you're comparing olives to olives, or you're comparing olive to grapes. Are the papers different? So the most common measure of heterogeneity is I-squared. About 50% is substantive heterogeneity. This shows less than 40% I-squared, so heterogeneity is low. So in this case, it's heterogeneity. Oh, sorry, this is going too fast, actually. I forget, did we do this last time? 50% is substantive heterogeneity, yeah? And if this shows less than 40% I-squared, so heterogeneity low. Is heterogeneity substantive here? Yeah? And in that case, it is. So there's high heterogeneity. Can you see the papers are distributed all over the place? Yeah? Less than 40% means heterogeneity is low. Yeah? So there's different scales, but I just use less than 40%, which means low heterogeneity, or more than 50%, which is high heterogeneity. There's a moderate heterogeneity as well, but I don't really use that as much. Okay. Yeah. Heterogeneity is differences in the papers, like intervention, the participants, where there are different types of people in there, and where the designs different, like where it was a randomized controlled trial and one was a not randomized controlled trial. Okay. So publication bias, let's do a blocker on it. We got a few more questions this time. Now, publication bias uses something called a funnel plot. Yeah. I'll just quickly show you a funnel plot. You can see my screen, yeah? So a funnel plot, if it's symmetrical, is fine. If it's asymmetrical, then there's a problem. Yeah. If it's symmetrical, that means that all the papers are present, because there's positive papers, there's negative papers, and in essence, what it means is that all of the results that you expect exist because of the fact that there is a natural distribution of all data. Yeah, like a bell curve. All data should be naturally distributed. Imagine this. Let's say the average height is 5 foot 8 inches in men. So you'd expect exactly the same number of men to be above that and the same number of men to be below. But if they're not, then there's an asymmetrical funnel plot, and therefore some data is missing. Okay. Now with that, we'll start our first game. Can you guys hear me clearly? Everybody's gone quiet. The silence is deafening. All right, which game, guys? Which game? Pirate's Voyage, Candy Quest, Fishing Frenzy, Monster Brawl, Tower Defense, Deceptive Dinos, Cafe. Racing is actually pretty crap, so I wouldn't advise that. Block Rush. Guys, come on. Crypto, Candy Quest. Let's see, who said crypto, who said Candy? Battle Royale. Oh my God, let's see who the tiebreaker vote is. Let me look at this. Let me look at the chat. Who's ordered what? Battle Royale. Let me look at the chat. Let me show you chat what games you guys want. The chat isn't opening properly. I can't see the chat. Battle Royale. Okay, fine. Let's go back to the blockhead in the host. Okay, so Battle Royale, somebody said. All right, we're going to choose Battle Royale. Actually, I was going to do a lot more in this class. The time runs out so quickly. Playblocket.com, guys. 8923682. Please note all of these games you can play offline as well. The link, you just do play.blocket.com and then you put this code in. Come on, let's see how many people are here. 14. Okay, let's go back. Let me just share the game to make my life easier. Post blocket. Let's go back to the blocket. Okay, shall we start? Everybody who wants to start is in. A few people missing. Okay. All right. I'm gonna start now. Oh, each round. Step 2. Answer questions correctly. Answer quickly to beat your opponent. Step 3. Showdown. Answer correctly and quickly to keep your energy. Step 4. Survive. Let's go. Guys, the class was stretched probably 10 minutes more because there's 2 quick exercises I need to show you. Sorry about that. Why are smaller studies absent? Yeah, they don't make it publication. Correct. Next question. 8 players remain. Oh my god, eliminates people. I didn't realize. Battle Royale. It's quite aggressive. Starting in 7 seconds. 6, 5, 4, 3, 2, 1. What is the common reason for application bias? Yes, because then people get more attention. 7 people left, 8 people left. Okay. We need trickier. Ooh. Yeah, because if it's neatly inverted triangle, then we know it's neat. Oh, 8 players. Nobody's getting eliminated. Nobody's being fired yet. I think we'll do 1 or 2 more rounds and then I quickly need to show you something. How's it going? Is it going well? Okay, I'm just come on, guys. Don't be getting eliminated. The questions are too easy. Too easy. Okay, How you guys doing? Alright, the fun part uneven. Because I guess application bias. Okay, all right. I'm going to stop this here. Guys, any questions before I show you guys something? Any questions? All right. I'll try and be quick, but I need to go show you guys some four important things. This is really, really important. Okay. Let me just go to my screen and share, and then you guys can see what I'm talking about. Okay. So the first thing is let's change the share to entire screen. And let's go to the GPTs. So if you have to, there's a code, usually it's 786M3, but there's this code which has all my GPTs here, yeah? And these can do things like risk of bias, which we'll go into next time. It can do various things, but the important one is this is meta. So this Meta Protocol Assistant. The Meta Protocol Assistant is amazing. Like I say, 4.0 is probably the best version to use, but it can write a whole Prospero protocol for you if you want. Yeah. So let's say we go to Meta Protocol Assistant 4.0, or let's say this one, and I say, can you write me? Basically, you can put the previous meta-analysis in. Protocol on drug eluting. It will literally write the Prospero protocol for you. You have just changed the introduction on drug eluting stents. Can you guys see this? Versus balloon. Voila, and it just writes for you. 4.0 is the best version to use, and it gives you a huge amount of detail. As you can see, all this is here. Yeah, so that is one of the best ways to write your protocol. You will write your extremely advanced protocol. And what you can then do is say advanced stats, and that'll give you something really advanced. Can you see it's giving you everything? Yeah. Use 4.0 because I've updated it on it to latest, but this basically advanced stats then gives you something even more advanced. So publishing a protocol is important because it means you have a 70-80% chance of success. Yeah. So that's one thing. The second thing I want to show you, which is quite important, is that you remember we had the app. Yeah. In the app is a section. Let me log into my app. This is the app I told you guys about last time. So if I go into this app, now what I may not do, so this is the odds ratio, risk ratio app that you guys used last time. Oh, I don't know where the downloads went. Okay, fine. Don't worry. So what this does is, if you go into the meta text results, let's say you generate the forest plot, you go to meta text results. What you can do, you can take the meta text results, and this is very, very important, because you can take the meta text results, and then you can put this into my other GPT, which is the results writer GPT. Yeah, the results writer GPT. So this is I'll show you the results writer. I've got GPTs that can do everything, like, well, quite a few things. So this is the meta protocol. Then there's the results writer, which is somewhere. No proportions game. It's the results writer. Let me search for it. I think that would be easier, because I have so many GPTs, I can't actually find it that easily. Is one that can help you write the results. Risk ratio. R code. Don't worry about that. I got GPT for everything. There's a results writing one. Let me just do 786. This is how you search for it. Yeah, results writer helper. Probably the easiest way to find it. Start a chat with it. And then what I do is I can give it the results of the meta-analysis that we just did. And then it can basically help you translate this thick piece of code to you. And then you can basically write your results. Let me see if I can actually do this for you today. Oh, yeah, here. So let me download this, and then you guys can quickly see. I'm sorry I'm taking over time, but this is really important, because if you understand this, then life will become. So this is a simple CSV file with some risk ratios. So what I'll do is that if I go to this, and I'll show you how this works. I upload the CSV. Okay, now this is important. So now you have your forest plot. Now the forest plot can be done in a number of styles. There's JAMA style, there's Revman style, there's RMA style. But this is very important. Meta text result. So this is the text result of the meta-analysis. Looks like dense code, yeah? You take this, put it in the GPT, the results writer one. I'm not going to even tell it what to do. It already knows. I've programmed it. Oh, no, don't do this. Voila. It knows what to do. I don't have to tell it anything. It's programmed to do something. Summary of the results. Oh, it was a risk ratio random effects model, which was 0.7209, indicating a statistically significant reduction in the risk associated with intervention compared to the control. This suggests the intervention may be beneficial in reducing the risk of the outcome of interest. And then tells you about the heterogeneity, tau scared, what they mean. And then, obviously, this is far, far too long. You can do it in different styles as well. Do in any GM style. And then this is pretty good, actually, any GM style. Yeah, it's telling you all of this. You can take this to write both your method section. So inverse variance method, Paul Mandel estimator, you don't need to know any of those. It's automatically programmed. If you don't change it, it's automatically programmed to give you the best result. But this is the other bit that I want to show you. This is the amazing bit of the app. So that is this, but if you want, you can also get a funnel plot out of it. So let's say I want to do a funnel plot. Where is it going? So it's giving you lots and lots of different radial plot publication. Bias, B-swarm. funnel plot. It gives you a nice little funnel plot, and you can see there's no variation, yeah? But not just that. Okay, what about, we want to write about this. Oh, that's interesting. Heterogeneity. I don't know how to interpret this Eggers test. Eggers test is a test of heterogeneity. Sorry, publication bias. Eggers test is a test of publication bias. I take it here to my GPT. Voila. It's giving me heterogeneity results. So now it's saying that, oh, the Eggers test, there is significant funnel plot asymmetry. Small study, there is bias. Then it does an analysis after removing outliers. And then it says after the outliers are removed, there's highly significant effect on intervention after removing outliers. Then all of this, it basically is telling you all of this, what it's saying. And this is English now. So you can take this and say, okay, studies B and B1 contributed the most heterogeneity, means they were more like olives than grapes. Yeah, this is amazing because this is not an ordinary GPT. Try and understand this. This is not an ordinary GPT. This is a GPT designed to take these results from this and convert them into something really, really useful. And then, so I've put all of these plots here. So heterogeneity, which is basically the variation. These are all these things, but you don't need to know how to interpret these plots, because actually, as you saw, by putting it in that ChatGPT, it will help you understand it. Yeah, these are all the heterogeneity ones. Now, publication bias, we talked about this. Let's say I specifically say, just give me publication bias. Yeah, you go back to the GPT. This is revolutionary, guys, because this, otherwise you need a statistician, which I wanted to eliminate. So I've created this GPT. This ordinary ChatGPT cannot give you this. You have to use the thingy thing, this specific specialized GPT, the results writer helper. It doesn't write the results for you. It translates them into English. Yeah. And then it does various other high I squared. So there's heterogeneity is high. It's 86.4%. There's significant heterogeneity. It's done all these little tests. Now, the reason I give you such advanced analysis is that for publication nowadays, you need to show you've done the most advanced stat possible. And yet, you've presented it all in English, which is amazing, yeah? All right. I'm going to stop here. Guys, anything else to ask? Sorry, we've gone on for a while. Guys, speak now or forever keep your peace. I don't think any of you spoken in the whole class. Let me look at the chat. No. Nothing more? Okay, all right. I'm going to stop here then. Anybody have any further questions, just text me, okay? I think most of you have my number. Thank you very much. Okay, bye. Bye.